Hello everyone, welcome to the next video in the series, and today we are going to explore Gateway Load Balancer. This is a really interesting topic from the security perspective, of course, because this caters the NVAs, and it's going to lessen the admin overhead and complexity of the architecture for sure. So let's try to understand the concept for our video. So as you can see here, let's suppose there is two virtual network. Here we have a VM, here we have multiple VM behind the Azure Load Balancer. And it is paired to the hub network, let's call it hub, where we are running the multiple NVAs, okay, behind the Azure Load Balancer. So the traffic will come here and it will go through the load balancer, go to the NVA and then to the respective VMs. This is usually the scenario. It may possible you have other NVAs here, okay, which is dealing with east-west or north-south separation NVA. This is again NVA. So east-west, north-south kind of traffic, they're managed by different set of NVAs. For example, if it is internal, east-west, then it will use this NVA, and if it is north-south, it will use only this NVA. We may have one behind the others as well. There are multiple ways of achieving this setup, but the point is there are certain challenges. There are certain challenges in this kind of setup. What are these challenges? Well, the very first thing is, when we deploy NVA and uh, we have to do a lot of networking. We have to manually redirect all inbound and outbound traffic through the NVA for inspection, right? So there is a lot of manual redirection. That is the first challenge. If anything is missed, then your security inspection is missed. And of course, your application services must be aware of the security appliance requiring changes in configuration to enforce security checks. You need to define UDRs everywhere, okay? And then you have to manage all these UDRs if something happens, right? Apart from that, for example, if an admin misconfigure or deletes a route, traffic can bypass security controls without any alerting mechanism. So the management is really tough. Management is really tough. Apart from this management, there is another challenge that comes is asymmetric routing. Yes, asymmetric routing occurs when inbound traffic follows a different path than the outbound traffic. In this traditional NVA based architecture, the return traffic may bypass the NVA, leading to security policy failures. All right, then there is another challenge of the high availability or scalability of your NVAs, right? Because it requires complex configuration and failure requires manual intervention sometimes. So there are certain challenges in this kind of setup, and that's the reason we have a Gateway LB recently GA, which can help us solve those kind of challenges. So let's understand what is Azure Gateway Load Balancer. So in Azure Gateway Load Balancer, what happens? We need not to expose our NVA behind the public load balancer. Rather, we have a load balancer here. And this load balancer is our gateway load balancer. All right, and there are certain concepts that we need to understand, and you will understand the beauty of this gateway load balancer afterwards. So what is gateway load balancer? It is a specialized SKU within Azure Load Balancer designed to facilitate the deployment, scaling, and management of third-party NVA or network virtual appliance such as firewalls. It has the various features like intrusion detection, prevention system, and custom appliances. Anything like that, right? So, how exactly it does that? Because it provides a transparent bump in the wire technology. What is bump in the wire? Yes, bump in the wire technology, ensuring that all traffic to and from a public endpoint is first directed through the NVA before reaching your application, maintaining flow symmetry and stickiness without manual configuration. What does that mean? That simply means the IP address of your VM, the IP address of your ALB, right? We can configure something like that. Once the traffic comes to this IP, the traffic will be chained to go to this load balancer, which is gateway load balancer, and it will send the traffic to the available NVA. NVA will do its part, the scanning, the threat analysis, everything, and the filtered traffic will go back to this IP, and the things will happen as it's supposed to be. So this piece become totally separate from all these UDS. No need to do the manual redirection UDS anything. On the public IP, you need to select gateway load balancer. I'll show you. So it's that easy. All right. So bump in wire. Okay. So this traffic flow you understood, right? It's very simple. Whenever traffic comes to any of the IP, you have for even load balancer, it works with the VM IP as well. The next is the gateway load balancer. Let me show you. It will make more sense. All right. So if I come to a virtual machine, let's say, okay. If I come to the virtual machine, I click here. All right, and I'll go to networking, network settings, where the IP is. IP is on the NIC. Let me click on the NIC. Under IP configuration, you'll find a setting, gateway load balancer. If you have a gateway load balancer in your network, you can simply select that, and all the traffic coming to this IP address, even going out of this IP address, will move to this gateway load balancer, which has what? Which has NVA to perform their threat analysis, scanning, intrusion detection, and intrusion prevention, all kind of filtering there. So unfiltered traffic will go there, filtered traffic will come back, and again it will come to the same IP, the same flow will continue. It would be absolutely symmetric, right? So this one is fine. I was showing you this is the IP address of VM. Similarly, this is on the IP address. So if you go to the load balancer, you see the front end IP configuration. If you go to this IP, you can do the same thing here as well, gateway load balancer, right? And when you create a load balancer, right, let me come to the basic. This is like create load balancer, okay? You select the gateway load balancer. This is the SKU that you're talking about, gateway, direct traffic to network virtual appliance. It could be internal. You see the public is grayed out. It could be internal and regional. So once you have your gateway load balancer in your network, then you have the option to select. I don't, because I don't have any NVA, because when you try to create it, it will ask you to add the backend pools, the NVA. I don't have any NVA as of now, nor I have that much money to create. But we are learning the gateway load balancer. This is good enough for the understanding. Okay, let's come back to our diagram. All right, now we can easily understand bump in the wire. It refers to the transparent inline deployment of security or network appliance, right? So traffic and inline right here, where the device process traffic without requiring any manual routing changes. In Azure, this concept is implemented using gateway load balancer. To insert NVA like firewalls or IDPs, IPs, or deep packet inspection appliances into traffic, because it is going to be absolutely separate here. Traffic automatic come and go, Everything will be managed by GWLB. So how bump in wire works in Azure Gateway Load Balancer? Let's understand this technology. Well, traffic from consumer resources, VM, load balancer, other services automatically flows through Gateway Load Balancer, as I have showed you the configuration done on the IP. And now it will automatically go to this place till now. So the only configuration we need is IP. We need to select the gateway load balancer. Then by default, traffic will go there. No UDS, nothing needs to be configured, no net ruling, nothing. Now, gateway load balancer encapsulates the traffic using VXLAN. This is something very interesting. VXLAN, okay, and sends it to the NVA. So this traffic, the traffic which is coming, is got encapsulated through VXLAN before it send it to the NVA. All right, and VXLAN is like wraps a normal network packet inside another packet so it can travel over different networks without interference. Ultimately, we need to keep whatever is going on when traffic comes to this IP, everything preserved as it is. So that's why this is happening. So VLAN is a network virtualization technology that encapsulate layer 2 Ethernet frames inside layer 3 UDP packets. So this allows network traffic to be carried over existing IP networks without modifying underlying infrastructure. In simple terms, VXLAN wraps a normal network packet inside another packet so it can travel over different networks without interference, right? So how does this VXLAN work in gateway load balancer exactly? Well, when traffic passes through GWLP, Azure encapsulate using VXLAN, encapsulate the traffic before it's sending to the NVA, right? The NVA receives the VXLAN encapsulated packet, process it, and then returns it to the GWLB, which means our NVA must support this technology, VXLAN, right? And once this, because it understands VXLAN, so it will do its filtering and everything. It will send the traffic back to the GWLP, and GWLP now removes the VXLAN encapsulation and forwards the traffic to the final destination through this load balancer. Okay, because filtering, everything is done. Now NVA inspects and processes the traffic. NVA returns the traffic to the GWLB or gateway load balancer, which then forwards it to the destination. This entire process happens transparently without the consumer VMs or load balancing being aware. Okay, because it has the information of everything what comes here. Okay, so that's how it exactly happens. And this is what the GWLB is. Now let's see the some architectural components of GWLB. Just like any other load balancer, this GWLB also has a front-end IP, okay? Like any other gateway, GWLB also have front-end IP, which would be private IP, as I have shown you, okay? Then second is it has the load balancing rules like any other, and it employs HA ports, okay, because there is NVA, we want different all the ports managed dynamically. So employ this HA ports rules to define how incoming traffic is distributed across backend instances, mapping the front-end IP configuration to multiple backend IP addresses and ports. Now backend pools, it also have backend pools, which are our NVAs. So backend pool. So it has all the same configuration as any other load balancer. Now backend pool could be virtual machine or instances in a VMSS handling the incoming request. The backend pool can include instances from any virtual machine within a single virtual network, just like any other load balancer. Now There's something interesting which is called tunnel interface. It enables NVA in the backend pool to handle network flows as expected, supporting both internal and external traffic directions. And so something really important is called chaining, which makes all the traffic to flow as it's supposed to be. And this refers to the process of linking standard load balancer front end or standard IP configuration of a virtual machine to a gateway load balancer that I showed you in the portal, ensuring that the traffic passes through the NVA before reaching the application. All right, so these are the architectural component of GWLP. Now, let's see the data flow and traffic handling. Well, incoming traffic intended for the application is first, just for the purpose of understanding this flow. Incoming traffic intended for the application is first encapsulated with VXLAN headers, and forwarded to the gateway load balancer. It's configured NVA after processing the traffic returns to the consumer resources such as the standard load balancer and arrives at the application virtual machine with the source IP preserved. This is what we have learned as of now. Now, this flow, IP encapsulation going back, coming, right? This flow maintains this GWLP, this scenario maintains flow stickiness to a specific instance in the backend pool along with flow symmetry, ensuring that packets traverse the same network path in both directions, which is crucial for stateful NVAs, right? Now, let's see, we understood the challenges with the usual approach of NVAs and the architectural component and how exactly it happens through chaining, NVA through tunnel interface. Okay, we have already showed you in the Azure portal. Now let's understand some key features and benefits of GWLP or Gateway Load Balancer. The very first is it's a transparent, I should write the benefits or key features. This is really interesting to understand. The very first is transparent integration. Well, integrates NVA seamlessly into the network path, allowing for advanced traffic inspection and processing without alerting existing network configuration. As you can see, no UDRs, nothing needs to be done, no manual redirection, management, or asymmetric routing. You only need to let the IP know there is a gateway load balancer, and it will take care, gateway load balancer will take care of everything, right? So it is a transparent integration. We don't know where the UDR are applied, all those multiple UDRs, different setup, different NVA for the incoming and outgoing traffic. It's very simple, rather uh, architecture, rather complex. That's why we can say it's simplified management. Okay, because enables easy addition or removal of NVAs in the network path, reducing management overhead and complexity. No UDRs, no issue with the scaling, and everything will be easy and automatically through GWLP, right? So scalability is not an issue because it allows for effortless scaling of NVAs to meet high traffic demands while managing cost effectively. Okay, then it also supports cross tenant and cross subscription sharing. However, it doesn't go beyond the region. All right, so these are some features of a gateway load balancer. Now let's understand a few more things about gateway load balancer, like it works on layer 3 or layer 4 like any other load balancer. Okay, and it forwards traffic transparently without modifying the packets. Okay, encapsulation that we have learned encapsulates traffic using VXLAN before sending it to NVA. So what exactly is it doing? It's not modifying packets. Okay, Now it sits between client load balancer. These are clients, okay, and the NVAs, and automatically redirects traffic to NVA for inspection and takes care of the flow, right? So you could say it is a middle layer. Now only load balances traffic to NVAs and not to backend applications. So this works with the NV only, not for with the application. So if you need application load balancing, use application load balancer, front door, or Azure standard load balancer, right? Then it works with the private IP, okay, and these are all should be in the same region. So it is region specific, okay. All right, so apart from this, there are certain things that let's try to understand the challenges that we talked about, how exactly the gateway load balancer solves those challenges. So with the standard NVA setup behind a public load balancer, you must manually redirect all the inbound and outbound traffic through NVA for inspection. Okay, and how this solves the GWLB? Well, because it's an transparent inline security layer, so no need to modify application configuration to enforce security. It automatically redirects all traffic through NVA without requiring app level awareness. Okay, this is useful for scenarios where multiple VNet connect to a centralized security hub, as we seen in our uh, design or diagram, ensuring consistent enforcement of security policies. So it can takes care of this automatically, no app level awareness needed. Now, traditional NV requires UDRs. This means every spoke VNet or workload subnet must have custom route table, and manually managing and maintaining UDRs across different or multiple VNet is complex and error prone. But in GWLP, no UDRs are required. Gateway load balancer automatically redirects all traffic to the NVA for inspection without the need for custom routes. Okay. And even if workloads are in different VNets, you can attach them to using gateway load balancer endpoints, ensuring traffic inspection without additional routing complexity. This simplifies operations in large scale environment with multiple spoke VNets and hybrid connectivity. Even express route and VPN can also be taken care by gateway load balancer because they do have their IP configuration and you can apply the same chaining methodology there. Then asymmetric routing occurs when inbound traffic follows a different path than outbound traffic, and it happens during the NVA. Return traffic may bypass the NVA. You don't know how exactly the traffic is configured, the architecture is designed, uh, but gateway load balancer ensures symmetric traffic flow by keeping track of inbound and outbound traffic sessions. The same security appliance handles both request and response traffic, maintaining security policies. As I have showed you, same appliance, and no need for SNAT preserving source IP encapsulation, VXLAN, everything we talked about. So no need for SNAT preserving source IP visibility for logs, threat detection, analytics. Okay. And finally, traditional NV are hard to scale. If traffic increases, administrator must manually add more firewall instances and distribute traffic using load balancer rules. And even failover requires sometimes manual intervention, but gateway load balancer automatically load balance traffic across multiple NVAs, ensuring no single instance is overloaded. If NVA fails, gateway load balancer detects it using health probe and reroutes traffic to a healthy instance. And the scaling security appliance becomes dynamic and automated without needing manual configuration as such. All right. So this is what the gateway load balancer is. People, this is not like very old. This is recently GA, and people are getting aware of this. And I'm pretty sure, as per the kind of features that it is offering in this kind of scenario where we have the NVAs, I'm pretty sure people are going to utilize gateway load balancer. All right. So I hope it was helpful. We got some new insights about the gateway load balancer. Well, thank you for watching, and you guys have a wonderful